Something impossible is happening at Mars' orbit. The interstellar visitor 3I Psi Atlas, which should be a frozen corpse this far from the Sun, has erupted into a blaze of activity that defies every model of cometary physics. In just 3 days, the object brightened by over 250 times, a surge so dramatic that observatories worldwide stopped their scheduled programs to watch. At Mars' distance, comets are supposed to be dead. The temperatures are brutal, the solar energy weak. The volatile ices that create those spectacular tails we associate with comets should be locked solid, dormant, invisible. Yet 3-eyed Atlas is burning brighter than objects half its distance from the Sun. Ground-based observatories are recording outbursts that pulse with clockwork precision. Spectroscopes are detecting emission lines that shouldn't exist at these temperatures. And the energy calculations point to a power source that conventional comet science says cannot exist. This isn't the first anomaly logged for 3I Atlas, but it's the most violent. And it's happening right now, visible to any telescope pointed at the Martian sky. The question isn't whether something extraordinary is occurring. It's what mechanism could possibly drive it. The first alert came from Catalina Sky Survey in the pre-dawn hours of November 12th. The automated systems flagged something unusual in what should have been routine tracking of 3I Atlas. The object had been barely visible for weeks, just another dim speck drifting through the outer solar system. Then, between consecutive exposures, it flared. Within hours, observatories across the Pacific confirmed what Catalina had caught. The Nordic Optical Telescope captured an expanding cloud of material already tens of thousands of kilometers across, growing at incredible speed. By the time Chilean telescopes came online, the transformation was complete. What had been a near-invisible object was now bright enough for amateur equipment to track. The verification cascade was unprecedented. Multiple automated systems triggered alerts simultaneously, something that almost never happens with natural phenomena. The Minor Planet Center issued an emergency circular, upgrading 3I Atlas to critical observation status. Teams that had been studying other targets pivoted their instruments toward Mars' orbit, where an object that should have been dormant was very much alive. But the real shock came when the timing patterns emerged. These weren't random outbursts. They were following a rhythm so precise that some observers initially suspected instrumental error. Every 8.4 hours, like a cosmic metronome, 3I Atlas would pulse. And with each pulse, the mystery deepened. Mars' orbit is where comets go to die. At 1.5 times Earth's distance from the Sun, the solar radiation that drives cometary activity drops to less than half strength. The equilibrium temperature plummets to the kind of cold that turns water ice into something harder than granite. Carbon dioxide, methane, ammonia, all the volatiles that create those spectacular cometary displays, they're supposed to be frozen solid, trapped beneath layers of dust and refractory material. The textbook says comets need to cross inside Mars' orbit before they wake up. That's when solar heating can penetrate the insulating dust mantle and reach the volatile-rich layers beneath. It's a predictable process, mapped out over centuries of observations. Comets follow rules. They brighten on approach, fade on retreat, with activity curves that match their distance from the Sun almost perfectly. 3-eyed Atlas is breaking every one of those rules. At its current position, the object should be receiving about 590 watts per square meter of solar radiation. That's enough to warm the surface to maybe minus 80 Celsius on the sunlit side. For comparison, comets typically need temperatures above minus 50 to show significant activity. The math is brutal and simple. There isn't enough energy available to drive what we're seeing. Yet the flares continue, each one releasing more energy than the Sun delivers to the entire nucleus in a week. Which raises the question that has the scientific community on edge. If the Sun isn't powering these outbursts, what is? The pattern emerged within the first 48 hours of observations, so regular that multiple teams independently calculated the same period. Every 8.4 hours, 3I Atlas erupts. Not approximately 8.4 hours. Exactly 8.4 hours, with a precision that natural processes rarely achieve. Each outburst follows the same sequence. First, a sharp brightening in the inner coma, visible in real time through large telescopes. Then, an expanding shell of material racing outward at roughly 2 kilometers per second. The ejected material forms asymmetric jets, consistently oriented in the same direction relative to the nucleus, suggesting either a fixed active region or controlled venting. After about 3 hours, the brightness peaks, then gradually fades until the next cycle begins. What makes this especially bizarre is the consistency of energy output. Natural comet outbursts, typically vary in intensity, triggered by factors like thermal stress, volatile pockets, or nucleus fragmentation. They're messy, chaotic, unpredictable, but 3I Atlas pulses like a machine, each burst releasing approximately the same amount of material at the same velocity in the same direction. The European Southern Observatory ran continuous monitoring for 5 complete cycles, searching for any deviation from the pattern. They found none. The timing held to within minutes, the intensity varied by less than 10%, and the jet orientation remained fixed. One researcher, speaking off record, called it disturbingly artificial before clarifying they meant artificially regular, not artificially made. But the distinction is getting harder to maintain as the data pours in. But the timing pattern was just the beginning. When spectroscopes analyzed the light from these clockwork eruptions, they found something that shouldn't exist at any temperature, let alone in the frozen void near Mars. When the first spectroscopic readings came back from Keck Observatory, the team thought their instruments needed recalibration. The emission lines were all wrong. During each flare, 3I Atlas shows strong signatures of ionized carbon monoxide, sulfur compounds, and something that looks remarkably like magnesium silicates, minerals that should be locked in the rocky matrix of the nucleus, not floating in the coma. The carbon monoxide detection was strange enough. CO2 dominates most cometary emissions at these distances, but 3I Atlas shows CO at levels that suggest either an unusual formation history or active chemistry happening right now. The sulfur compounds appear only during peak flare intensity, then vanish completely during the quiet periods, as if they're being manufactured and destroyed in each cycle. But it's the silicate signature that has researchers scrambling for explanations. These are refractory materials, the kind that need temperatures above 1000 Kelvin to vaporize. At Mars' orbit, in the frozen depths of space, nothing should be hot enough to liberate these minerals. Yet there they are, clear as day in the spectral data, appearing with each pulse like smoke signals from an impossible fire. Teams at NASA Goddard have proposed exotic chemistry, perhaps triggered by cosmic ray impacts or internal radioactive decay. Others suggest we're seeing subsurface pockets of primordial material preserved from the object's formation, but neither explanation accounts for the regularity of the pattern or the specific mix of detected species. The spectroscopy tells a story of chemistry that shouldn't be happening, powered by processes we don't understand. The spectroscopy tells a story of chemistry that shouldn't be happening. But when physicists calculated the actual energy required for what we're seeing, the story went from improbable to impossible. The math doesn't lie, and the math says, this is impossible. Each outburst from 3I Atlas releases approximately 10 to the 18th joules of energy. That's roughly equivalent to a modest nuclear weapon detonating every 8.4 hours for weeks on end. At Mars' orbit, the total solar energy hitting a nucleus the size of 3I Atlas, estimated at 5 to 10 kilometers across, amounts to perhaps 10 to the 16th joules per day. The object is outputting more energy in each burst than it receives from the sun in a week. Even if the nucleus was a perfect solar collector, converting every photon to outgassing energy with impossible efficiency, the numbers don't work. The mainstream explanation involves phase transitions in exotic ices, particularly the conversion of amorphous to crystalline water ice, which can release stored energy. But that process typically produces maybe 10% of what we're seeing, and it doesn't pulse with metronomic regularity. Another hypothesis suggests volatile pockets under pressure, but the consistent energy output argues against random pocket collapse, which leaves the frontier hypotheses. Internal heat sources like radioactive decay could provide steady energy, but not at these levels unless the nucleus contains uranium concentrations that would make it a flying reactor. Tidal heating from an unseen companion has been proposed, but no companion has been detected despite intensive searches. Some researchers, very quietly, have started calculating what kind of artificial power source would be needed. Those calculations remain unpublished, but the number that keeps appearing in private discussions is 10 gigawatts. Sustained. That's the output of a large nuclear power plant, somehow packed into a 5-kilometer ball of ice and rock. Some researchers, very quietly, have started calculating what kind of artificial power source would be needed, and those calculations might explain why 3I Atlas is no longer following its predicted path. Every pulse pushes 3I Atlas slightly off course. The effect is tiny but measurable, a change in velocity of about 0.3 meters per second with each outburst. Over weeks, these small nudges have accumulated into a deviation of several hundred kilometers from the predicted path. What's remarkable isn't the existence of non-gravitational forces, which are common in active comets, but their consistency and direction. The jets always fire in roughly the same orientation relative to the sun, creating a thrust vector that's gradually reshaping the orbit. JPL's navigation team has had to update their ephemeris 3 times in the past week, each revision accounting for the cumulative effect of these regular pulses. The implication is staggering. If these forces continue, 3I Atlas will pass significantly closer to Mars than originally calculated. Not impact close, but close enough that Mars orbiters might get detailed images if they can slew fast enough to track the speeding object. Some teams are already proposing that this trajectory change isn't random, that the regular pulses are acting like a crude course correction system. That's speculation, but it's speculation backed by increasingly precise orbital measurements. The European Space Agency has quietly tasked their Mars Express orbiter with contingency observations, while NASA has begun calculating whether any active Mars missions could capture close-up data. The window would be brief, perhaps minutes, but it might be humanity's only chance to see this object in detail. If the trajectory holds, if the pulses continue, if the impossible keeps happening. The scientific community has split into 3 camps, each defending their interpretation of the accumulating anomalies with increasing intensity. The conservative camp, led by established cometary scientists, maintains that everything about 3I Atlas can be explained by exotic but natural processes. They point to the crystalline ice transition, unusual volatile mixtures, and the possibility of large-scale fragmentation events. Yes, the regularity is unusual, they argue, but nature produces surprisingly regular patterns all the time. Geysers on Earth, pulsars in space. These phenomena show that natural processes can tick like clocks. The energy excess, they suggest, comes from chemical reactions we don't fully understand, perhaps involving hydrogen peroxide or other supervolatiles formed by cosmic ray bombardment during the object's interstellar journey. The moderate camp acknowledges that conventional explanations are struggling but stops short of invoking anything revolutionary. They propose that 3I Atlas might represent a new class of object, formed under conditions unlike anything in our solar system. Perhaps it originated in a binary star system, where radiation fields created exotic chemistry. Perhaps it's a fragment of a planet that formed close to a neutron star. Strange, yes, but still natural. Then there's the frontier camp, small but growing, who argue that the accumulation of anomalies has passed the threshold where natural explanations remain plausible. They don't use the word artificial in their papers, not yet, but in conference hallways and private communications. The possibility is being seriously discussed. The regular pulsing, the consistent energy output, the apparent course corrections. Together, they paint a picture that's increasingly difficult to reconcile with known physics. The debate rages in conference rooms and research papers. But while scientists argue 3I Atlas continues its show, and for the next 3 weeks, anyone with a telescope can witness the impossible for themselves. For the next 3 weeks, 3I Atlas remains visible to telescopes in both hemispheres, tracking through the constellation Pisces toward Aries. Amateur astronomers with 8-inch or larger telescopes can spot it as a fuzzy patch, brightening dramatically during outburst peaks. The optimal viewing window runs from midnight to dawn, with the object highest in the sky around 3 a.m. local time. During flare events, which occur every 8.4 hours, the magnitude can reach 11, bringing it within range of high-end binoculars under dark skies. The next predicted outbursts will occur at approximately 02:15 UTC, 10:39 UTC, and 19:03 UTC, though observers should start watching 30 minutes early as the brightness ramp-up is gradual. Professional observatories have opened their data streams to public access, an unprecedented move reflecting the extraordinary nature of the event. The Virtual Telescope Project is providing live feeds during each predicted outburst, while radio astronomers are monitoring for any emissions coinciding with the optical flares. So far, radio silence, but multiple arrays remain pointed at Mars orbit, waiting. The close approach to Mars happens December 3rd, when 3I Atlas passes within 14 million kilometers of the red planet. If the current activity continues, Mars orbiters will have the best view of any instruments in the solar system. NASA has preemptively cleared observation time, and ESA is repositioning Mars Express for optimal coverage. The images, if successful, could resolve features just meters across on the nucleus. We might finally see what's driving these impossible outbursts. What happens with 3I Atlas over the next month could fundamentally reshape our understanding of comets, or of something much more profound. If the outbursts continue with their clockwork precision all the way through solar approach, we'll have documented behavior that no current model can explain. If they stop suddenly, that's equally revealing, suggesting a finite energy source or a mechanism tied to specific conditions. The James Webb Space Telescope has been allocated emergency time for infrared observations during the next flare cycle. JWST's instruments can detect heat signatures and molecular emissions invisible to ground-based telescopes, potentially revealing the power source driving these eruptions. The data downlink is scheduled for November 28th, with preliminary results expected within hours. The evidence keeps accumulating. The patterns keep holding. And Three-Eyed Atlas keeps flaring, right on schedule, impossible and undeniable, out there at Mars orbit where comets are supposed to be dead.